Hello and welcome. Today we're going to be discussing an introduction to applications of quadratic functions. Previously we've talked about factoring quadratics and solving quadratic equations. Now we're going to be putting those into applications, or word problems. First, let's practice. If 8 is added to 7, find the result. So 8 is added to 7, meaning we're starting with 7 and then we are adding 8. The result is going to be 15. If 8 is added to its square, find the result. 8 is being added to something, so I've got something and I'm adding 8. 8 is being added to its square, so I'm going to start with the square of 8, or 8 squared. 8 squared is 64. 64 plus 8 is 72. Third, find the area of a rectangle whose width is 5 and whose length is 2 less than the width. I'm going to draw a quick picture. Anytime you're dealing with an application problem that has a shape, I highly suggest drawing a picture so you can visualize what's happening. Here's my rectangle. My width is 5 and my length is 2 less than the width. So my length is going to be my width, which is 5 minus 2. So basically what we did is we said L equals W, your width, minus 2. 5 minus 2 is 3, so your length is 3. I need to find the area of this rectangle, so please remember area is length times width. My length is 3 and my width is 5, so my area is 3 times 5, which is 15. Last, find the area of a rectangle whose width is 9 and whose length is 2 less than the width. So again, I'm going to go ahead and draw a picture. Here's my rectangle. It has a width of 9, so my width, W, equals 9, and the length is 2 less than the width, again. So I'm going to take my width and subtract 2, and that will tell me what my length is. Well, since my width is 9, my length is going to be 9 minus 2, which is 7. So my width is 9 while my length is 7. To find the area of this rectangle, I'm going to use my formula, where area equals length times width. Since my length is 7 and my width is 9, my area is 63. On this next slide, we're going to go through a similar process, except we're going to be using our sentences to write quadratic equations. The sum of a number and its square is 42. Sum means addition, so I know I am adding two things and obtaining 42. The two things that I am adding are a number, I'll call that x, and its square, so that would be x squared. So I take x and I add x squared and I get 42. And now we must solve this. Step 1, get a 0 on one side. So since my x squared is positive, I'm going to leave it and move my 42 from the right over to the left by subtracting. And then I'm going to rearrange these so they go from highest to lowest exponent. So I start with the positive x squared, then my positive x, and my minus 42, all equals 0. From here I factor using my diamond. On top I have a negative 42. On bottom the coefficient of x is just a 1. And my two numbers are positive 7 and negative 6. So I split up my positive 1 with a positive 7x minus 6x minus 42 equals 0. Splitting this down the middle, I take out a GCF of x, leaving me with x plus 7. And on the right, I can take out a negative 6, leaving me again with x plus 7. From here, I see a common factor of x plus 7, which I factor out, leaving me with an x minus 6. To solve, I take each of these factors, x plus 7, set it equal to 0, and my second factor, x minus 6, and set that equal to 0 as well. Solving them both, I find from the left that x will equal negative 7, and from the right, I find that x will equal positive 6. So I have two solutions for this application. X may equal negative 7 or positive 6. Go ahead and take a moment to pause the video and try the next one on your own. Sum again means add. You are adding two things. The first thing is 12 times a number. I'm going to call that 12x. The second thing is twice that number's square. That number's square is x squared, and I want twice that, so I have 2x squared. So when I add 12x and 2x squared, I get 12x plus 2x squared. This sum is 14, so that's why I write equals 14. Now that we have our equation, we make sure that we have a 0 on one side by subtracting the 14 from the right over to the left. Once I subtracted that 14, I rearranged everything so that my highest exponent, this 2x squared, went first, and then the second, which was the 12x, followed by my minus 14. Once I rearranged everything in the correct order, I factored, and after factoring, I wrote my two equations to solve for x. So your two answers should have been x is negative 7 or x is positive 1. Now we're going to go into difference. The difference means subtraction. I want the difference between 3 times a number, so that's going to be 3x, and its square. The square of the number would be x squared. When I'm taking the difference, I take the first number 3x and I subtract the second thing, which is x squared. The difference of these two is, so equals a negative 10. Again, just as in the previous slide, I need a 0 on one side, but now notice your x squared is negative. So I'm going to add my x squared from the left over to the right, and I'm also going to subtract a 3x. Doing this leaves me with a 0 on the left-hand side. And on the right, I'm going to rearrange these so I start with the highest exponent, x squared, and decrease down to my constant term, negative 10. Now from here, I factor using my diamond and solve. I have a negative 10 on top and a negative 3 on bottom, so my two numbers are negative 5 and positive 2. Rewriting my negative 3, I have x squared minus 5x plus 2x minus 10. Splitting down the middle, the GCF of the left is x, and I'm left with x minus 5. On the right, I take out a positive 2, leaving me with x minus 5. I see x minus 5 repeated, leaving me with an x plus 2 when I factor it out. All of this will equal 0. Notice at first it was on the left. You may move it to the right, it doesn't make a difference. I think it's a little bit easier to have the equals 0 on the right. From here, I take each of my individual factors and set them equal to 0. So my first equation is x minus 5 equals 0, and the second is x plus 2 equals 0. Solving each of these equations, I find x equals 5, or x may equal negative 2. Go ahead and take a moment to pause the video and try the next one on your own. I would like to go ahead and change this negative 80 to a negative 90, otherwise the problem won't work out. So please go ahead and change that and then proceed. Your two answers here should have been x equals 9 or x equals negative 5. From here, we're going to go into another rectangle type of problem. The length of a rectangle is 5 less than 3 times the width. The area is 24 square inches. Find the dimensions of the rectangle. So we have a rectangle. We are trying to find the dimensions, meaning the length and the width. Step 1, we're going to assign variables. Since I'm finding length and width, I'm going to go ahead and let L be length, and I'm going to let W be width. Step 2, identify relationships. My first relationship is that the length of a rectangle is 5 less than 3 times the width. So writing an equation for this relationship will come in our next step, step 3. Our second relationship is that the area is 24 square inches. So step 3, we write our equations. Length of a rectangle is 5 less than, so we're going to take something and subtract 5. It's 5 less than 3 times the width, so we are subtracting 5 from 3 times the width. That is the equation we write from our first relationship. Relationship number 2, the area is 24 square inches. So I have 24 square inches being your area, which is length times width. From here, step 4, we solve by substitution. So I'm going to take my length and replace it in my second equation for L. What I end up with is 24 equals 3w minus 5 all times my width. All I did is I replaced this L with the 3w minus 5. From here, I'm going to go ahead and distribute my w. 24 equals 3w squared minus 5w. And this should look familiar. We now have a quadratic that we can solve. I'm going to get a 0 on one side by subtracting my 24 from the left over to the right. So I have now 0 equals 3w squared minus 5w minus 24. We factor and solve. To factor, I use my diamond. I multiply the 3 and the negative 24 to get negative 72, and I'm adding to a negative 5. Unfortunately, here there are no two numbers that are going to work, so we're going to go ahead and stop here. You will learn how to solve an equation like this in later lessons. Let's go ahead and try it again. I'd like for you to pause the video and try all 4 steps on your own before I walk you through them. Step 1, again, we're going to assign our variables. We are finding dimensions. Again, my dimensions, I will let L be length and W be width. Step 2, I'm going to identify relationships. Relationship number 1 is that the length of a rectangle is 6 inches less than twice the width. Relationship number 2 is that the area is 32 square inches. Step 3, I write my equations. From relationship number 1, I find that L equals 6 inches less than twice the width. So I start with my twice the width and subtract 6. Relationship number 2, area is 32 inches. So 32 inches equals length times width. Step 3, I solve by substitution. So again, I take my L, which is 2w minus 6, and I replace it for L in my other equation. So I have 32 equals 2w minus 6 all times w. Distributing your w, I end up with 32 equals 2w squared minus 6w. To solve this quadratic, I need a 0 on one side, so I subtract 32 from the left over to the right to get 0 equals 2w squared minus 6w minus 32. I see a greatest common factor of 2, so I factor that out, leaving me with w squared minus 3w minus 16. All of this is equal to 0. Now we use our diamond on the inside if possible. So on top I have a negative 16, on bottom I'd have a negative 3. Unfortunately, again, there are no two numbers that will multiply to negative 16 and add to negative 3. So we'll go ahead and stop here. You will again learn this in future lessons. My goal with this slide and the last one is for you to be able to write and set up a system of equations in order to solve this type of problem. So factoring and solving from here, I'm not entirely concerned with. A rectangular garden, 3 yards by 4 yards, is too small. The area of the new garden needs to be 7 times the area of the old one. This will be accomplished by digging a border of uniform width on all 4 sides. What should be the width of the border? Your hint is to draw a picture. I'd like to leave you here. This will be your challenge question for the day. Go ahead, draw your picture, and see what you can do to solve. Thank you for watching, and I hope you enjoy the rest of your day.